Hello. Today I will be solving problem 58E on this physics problem. It says a stuntman drives a car over the top of a hill, and we're given the radius of the circle is 250 meters. It says what is the greatest speed at which he can drive without the car leaving the road at the top of the hill. So first, let's draw what the figure gives us. So let's pretend this is a hill, and this is our circle. Our radius is 250 meters, and this is the vehicle. So what we could do first to make this simple is to draw a free body diagram. So let's do that. So this is our hill that we can visualize, and this is our vehicle. Drawing a free body diagram will list the forces, which is force of gravity. Going down is mass times gravity, and going up is normal force. So normal force is equal to mass times acceleration. And because these two are directly opposite, or they basically are equal to each other, so the normal force is proportional or equal to the force of gravity. So force of gravity is equal to the normal force. So we could write our variables. So mass times gravity is equal to mass times acceleration. However, for this we cannot use this acceleration because we need to use the centripetal acceleration. And so let's find it really quick. So this is just this for the side, which I'll draw really quick. So this is our triangles, okay? Just two triangles. They're not right triangles, but two triangles. So we have velocity 1 and velocity 2, and this is delta v, or change in velocity. And we have this one, the radius and radius, and here is our v and delta change in time. So this draw our theta. So you have velocities and change in velocity, and this is radius and velocity times change in time. So we could equate this ratio as change in velocity over v is equal to v times change in time over r. So let's make this move over here really quick. So delta v over v is equal to v times delta t over r. So we can rearrange these equations. So we could set it as delta v is equal to delta t over v squared r. And we can send this right here. Delta v over delta t is the same as acceleration. So acceleration is velocity over time. Change in velocity over change over time. So this will now become a. So our a given is v squared over r, our centripetal acceleration. So going to this equation here, we'll bring it back up to make it easy. Mass times gravity is equal to mass times acceleration. But we see from here, our acceleration is v squared over r. So now we'll change it. So mass times gravity is equal to mass times v squared over r. And now it looks more polished. So we see here we have both m's on both sides, so we can cancel like terms. So cancel out the m's, and we're left with gravity is equal to v squared over r over radius. So now plug in our values. So gravity is 9.8 meters a second squared times velocity, which is not given, but our radius is given, which is 250 meters. So 250 meters. And so now let's solve our given formula, shall we? So we see here 9.8 meters is equal to velocity squared over 250 meters. What we could do is multiply 250 on both sides. And we're left with 2,450 is equal to velocity squared. And to get rid of the squared, I'll just square root the other side. So it's square root 2,450 is equal to velocity. And to solving the square root of 2450, it becomes 49.49 meters a second is our velocity solved. So it says, what is the greatest speed at which he can drive without the car leaving the road at the top of the hill? Well, the answer to that is he can drive 49.49 meters a second before leaving the top of the hill. And this is our answer. So thus, we drew a free body diagram, found out that normal force is equal to the force of gravity, but we cannot use acceleration. We need to find centripetal acceleration. And we did some quick calculations here, and this is our formula for centripetal acceleration. So we plugged this in, and then did some work, and then fill in the variables that we were given, and then we were left with our velocity as 49.49 meters a second. So thank you, and this concludes our problem.